Introduction to PCB. A printed circuit board is used to electrically connect various components using tracks, pads, etc. Characteristics of PCB. The traces present on the PCB consists of flat, narrow copper foil. The resistance of the conductor is determined by the thickness of the trace. Steps in manufacturing a PCB. PCBs are manufactured using a CAM system, which involves a lot of processes. Panelization, holding a PCB. Copper patterning, pattern developed on a photomask. Lamination, laminate the board. Drilling, drilling holes in a PCB. Plating and coating. The copper PCBs are coated with solder tin or gold over nickel. Legend printing. Other useful information as to where the test points are. Switch settings are printed. Types of PCB. The various types of PCBs are as follows. Double-sided, single-sided. Single-sided consists of one layer of copper on a rigid base material, where double-sided consists of two layers of copper on a rigid base material. Flexible. It consists of a single conductor layer on a dielectric film. Multi-layer. They are boards with more than 3 copper layers on double-sided boards which are stuck to each other with a particular glue. Flexi-rigid. Flexi-rigid boards consists of mixture of copper conductor layers on a dielectric film and rigid copper material. Metal-backed. Instead of copper in LED technologies, aluminum-backed PCBs are used. Buried and blind vias. In multi-layer boards where only some conductor patterns are required, this pattern of buried and blind vias is used. Controlled impedance. Controlled impedance circuit boards are used in applications which require great signal integrity. Microvias. Microvias are boards with connecting holes throughout. Copper plating on ceramics. For electrolytic processes, the PCBs used are made of ceramic, which are then coated with copper and has nickel, gold or silver finish. Microwave RF. The microwave radio frequency PCBs are used in cell phones as they can respond to change in the signal. Sequential builds. It is similar to multi-layer PCB. Copper invar copper. This PCB consists of a layer of invar sandwiched between two layers of copper. Invar is a nickel-containing iron alloy. Heat sink bonding. In this type of PCB, aluminum is fabricated and bonded to the board to enable removal of heat. Introduction to soldering. Soldering is a process of establishing a mechanical and electrical joint between certain metals. This is done with the help of a solder. Solder. A solder is a fusible metal alloy which enables various metal pieces to join together. It is essential that the melting point of solder is lower than that of those metals. Types of soldering. Based on the types of solder used, the process of soldering is classified as soft soldering, silver soldering, and brazing. Soft soldering. This type uses soft tin lead alloy as a filler metal with melting point less than 400 degrees C. Silver soldering. Silver soldering, also known as hard soldering, consists of an alloy made up of silver with melting point close to 740 degrees C. Brazing. Brazing uses a brass alloy and requires very high temperatures to melt. Soldering techniques. The different soldering techniques are conduction soldering. The conduction soldering process is basically the traditional hand soldering technique. Induction soldering. Induction soldering uses induction heat to melt the solder. Hot bar reflow. It is a selective soldering method where solders are heated using thermodes for melting. Laser. This method is used at a power of 30 to 50 watts for electrical connection joints. Pipe soldering. Copper pipes or tubes are joined by this method, a common practice in plumbing. Infrared soldering. Infrared saws are led through fibers which focus on the material to be joined, and soldering is done. Resistance soldering. An electric current is passed through the solder which melts it in resistance soldering. Mechanical and aluminum soldering. It is similar to brazing operation, but the difference here is zinc alloys are used as filler to join aluminum metal parts. Wave soldering. In wave soldering, the metal parts that need to be soldered are kept in place with adhesive. Then the solder material in the form of a wave is made to pass through it such that the solder metal is on the pins and pads and not on the entire PCB. Hand soldering. Hand soldering is a traditional form of soldering which is done using a solder gun and a thin wire of solder, and components are soldered on the PCB. It is still used at times. Reflow soldering. In this process, a solder paste is used to stick components on the pads, after which the entire assembly is placed in an oven. Stained glass soldering. Soldering tips made of copper are used in this technique, which generates three-dimensional stained glass. Desoldering. Desoldering is a process of removing solder and components from PCB for troubleshooting or repair or replacement. Desoldering techniques. These are the following desoldering techniques. Through hole. This technique involves heating of one joint till the solder is molten and the connection can be removed. Surface mount. This technique involves cutting the leads of surface mount components and removing the excess solder with soldering gun. Blowing hot air. When the components are closely packed in an IC, a special heat gun is used to heat the joint without melting other components. Desoldering tools. Tools used for desoldering are hot air guns, desoldering pumps, heated soldering tweezer, and vacuum and pressure pumps. Desoldering materials. Materials used in desoldering are solder wick, removal alloys, removal fluxes. Electrostatic discharge. Electrostatic discharge is the charge present between electric components when placed in contact with each other. So when soldering components on a board, precaution to avoid ESD must be taken. Heat sink. A heat sink is a device which cools the device by dissipating heat into the surroundings. Good soldering practices. Some steps must be done to ensure that the process of soldering is done smoothly. Coating the tip of soldering gun with solder, warming up the soldering gun sufficiently. Wipe the tip off with a wet sponge once done. Anti-static material handling. As discussed earlier, components that generate charge when in close contact are anti-static materials, and they need to be packed in special polyethylene bags to ensure no charging is done. Zero defect soldering. A zero defect soldering can be attained by using dry film solder mask and best practices in soldering.